Alright, so you can also do some other really nice things with the derivative as well. So finding a stationary point is one of them. Now it's called a stationary point. A stationary point is when a function is neither increasing nor decreasing. In other words, stationary points, another way to think of them is calling them turning points. Now, in the case of our pilot, which I've spoken about several times now, in the case of our pilot, he has two stationary points. Doesn't mean his plane's not moving, it just means his plane's not going up and his plane's not going down. So a stationary point is obviously taking place here, and a stationary point is taking place there. Now we want to find the exact moments at which those stationary points are taking place. So we can use the derivative to let us to do that. We know that f dash x in this case is equal to, so there's our derivative function. Now remember, the derivative function tells us the gradient. That's what f dash x is. It's the gradient at any given point. So what we really want to know is, when is the gradient of our pilot's ascent or descent equal to 0? So to find a stationary point, let f dash x equal 0. So 0 equals 12x squared minus 400x plus 2500. Now you really just need to solve that from there. Now what are your options for solving it? I'm going to start with probably the one you're least comfortable with, completing the square. You can also try factorizing it, but it might work, it might not work. You can also try your quadratic formula, which always seems to work. Negative b plus or minus the square root of b squared minus 4ac. So I'm going to use that method, solve. So when you put that all into that, you get x equals 25 or 8.333 recurring. Alright, so let's interpret those results. There is a stationary point happening here at the 25-second mark. There is another stationary point happening here at 8 1/3. So the question was, when does the pilot's altitude have a rate of change of 0? At those 2 points. Now we could say at what altitude is the pilot's rate of change equal to 0? If we know our x values, we can easily find our y values by subbing into our original formula. We can find our y value, by subbing into our original formula, because that gives us our altitude. So that's how you can find stationary points. We probably need to do a little more with stationary points, but there is our basic idea.